well, that's interesting. I'm recording today, by the way, because we're missing so many people. How do we get this? All right, pay attention. The ellipse has a center of -2, -1, a horizontal major axis of length 10, and a minor axis of length 5. That is the entire major axis, 10. 10 is equal to what? 2a, right? 2a is the whole length of your major axis. So this is x plus 2 squared over a squared. 25 tells you that a is equal to 5 because 2a is equal to 10.
Oh.
Yeah, don't miss that. Don't miss that. So if 2a is 10, a is 5. If 2a then is also equal, 2b is equal to 5 over here, the minor axis is like 5. So then the b is equal to 2.5. So we're going to add plus or minus 2.5 to the y dimension because we see that the horizontal major axis means it's wider than it is tall. So we're going to put the larger number underneath the x plus 2 squared over 25 plus y plus 1 squared over 6.25 equals 1. Number 2, you have a vertex at 0, 7 and a co-vertex at -3, 0. So you're getting hints that this thing is centered at the origin. And then your A value is 7 and your B is 3. So 0, 7 means it's going to go vertical on your major axis. And so you're going to put the larger number under the y. So x squared over 9 plus y squared over 49 equals 1. Number 3. You had 144x squared plus 36y squared equals 144. Just divide through by 144 so you can get the equals 1 on the right side. So the x term goes away. The y term becomes y squared over 4 equals 1. So your A value or your B value here, the larger one is going to be under the y term. The smaller one, since it's not really there, we know that it's 1. So your co-vertices are plus or minus 1, 0. Your vertices are 0, plus or minus 2. Number 4. Standard form, you simplify by completing the square. And you will have x minus 8 quantity squared over 4 plus y minus 2 squared over 12 equals 1.
Why would I have gotten 4 instead of 8 when I got 2 right? Why did I get 1 number wrong?
Okay, you're talking about at the center?
Yeah.
So that was an easy mistake because what you had is you were going to gather your x terms together over here. 3x squared minus 48x. You pull out the 3, and now you're left with x squared minus 16x. Okay, so there was probably some sort of a factoring issue there. All right, so then when you complete that square, you're going to have plus 64. Add 64 to the other side, and then divide back through by the 12. Okay, so the next we do 1 to 4, 10 to 12. Where's 10? There it is. X squared over 16 plus y squared over 36 equals 1. The larger number is under the y, so that's your major axis. It's going to go vertical. A is equal to 6, B is equal to 4. You plot those points out. It is centered at the origin because you have no minus terms with the x. Then x plus 3, quantity squared for number 11 over 25, y minus 2 squared over 4. You've got it going horizontal this time. A is 5, B is 2. So plus or minus 5 from your center, which is -3, 2. And you plot that. Okay, swimming pools. Who's got a pool at home? It's fun, right? Okay, who takes care of the pool? Do you take care of the pool? You don't take care of the pool?
Oh, that's my new personal.
Yeah. You don't ever do the vacuuming or the brushing or the cleaning out the skimmer basket to get the frogs out. Oh, your family does. Yeah. It's fun. I mean, the first time you get a frog in the skimmer basket, you got to get rid of it, or
Sometimes I'll skim the leaves out.
yeah, there you go. Right. Yep.
We got a crab like this.
In the pool.
Yeah, stupid. That was like,
How did you get it
I
there?
don't know.
That is crazy.
We've done a snapping turtle.
In the pool.
There's like a canal and our behind and our fence wasn't like our fence had a hole in it because we had a new fence and like this like big turtle came in and we had the stream around our yard and we had like rip the stream to make a net because it's so big and then because we got rid of the stream in the anyway.
Yeah.
But we like rip it and like catch it and
So show me how big.
The snapping one. It was like this big.
So heavy.
Yeah, it was heavy. It took like my dad. We had like a bunch of our neighbors come over, and like we had to get in the pool, but then they were never freaked out because like well, I was a 10,
Yeah.
but because it was like a snapping one, it actually quite hard to use.
Yeah. Oh,
It had like one of those seats. It was really creepy water.
crazy. Didn't think I'd get that for a pool story. That's great. That's amazing. So you got an elliptical pool here, 12 feet long, 8 feet wide. Consider the longer thing to be your vertical. And so you'll end up with x squared over 16 plus y squared over 36 equals 1. Skip ahead to 14. We'll save the space probe for the weekend homework. Write an equation of the circle if the endpoints are diameter 5, -7, and -2, 4. Tricky one. Was this one fun?
Yeah.
Yeah, of course it was. That's right. All right, so diameter means you have 2 points on the end of the circle. What's in the middle of the diameter? The center of the circle is right in the middle of the diameter. So, you have a couple things you need to do. First of all, how long is the diameter? You use the distance formula to calculate how long it is. The distance formula tells you that d, diameter, is going to be the square root of 5 minus -2 squared plus -7 minus 4 squared. So you get 7 squared plus 11 squared, which is going to give you the square root of 170, around 13.04. Half of that, 6.52, or root 170 over 2 is your radius. Now, where's the center? Well, do you remember ever seeing the midpoint formula? Yeah, a long time ago. Midpoint formula is the midpoint between 2 points is going to be the average of their coordinates. So you're going to take 5, this time plus -2, and then divide by 2. So 5 plus the -2 is 5 minus 2, which is 3, divided by 2 is 3/2. -7 plus 4 gives you -3, divided by 2 gives you -3/2. So that midpoint of your diameter is your center. So now you have your center, you have your radius, you write your equation. X minus 3/2, 20 squared, plus y plus 3/2, 20 squared equals r squared, which is 170 over 4, or 85 over 2, or 42.5. All right, number 15, another one to make you think a little bit. Equation of the circle with center at -6, 5, tangent to the x-axis. Tangent means it touches in how many points? 1 point. So if it's only going to touch at 1 point, that means that that point is the length of, it's going to extend, it's going to be on the outer rim, right, of the circle. So if we take the center going out to that point, that length is going to be our radius. So -6, 5, let's go from that point downward to the x-axis, which is a distance of 5 away, right? So we know that r is equal to 5. We have our center at -6, 5. So it's x plus 6 squared plus y minus 5 squared equals 25. Circle, sketch it. Completing the square, x minus 2 squared plus y minus 1 squared equals 9. And then you sketch. You've got 2, 1, radius of 3. Start at 2, 1, go over 3, up 3, down 3, and you're done. Alright, number 17, that was fun. Let's skip ahead for a minute. 18, I'll come back to 17, don't worry. 18, x squared plus y squared equals 9. You just read the graph. 19, oh, this is a very practical problem here. Can I get cell phone service when I'm out on a nature hike? When I'm unplugging from electricity and all of the technology to go out in the wild blue yonder, can I still get my cell phone reception? Okay, the answer is yes in this case, because if you have 9 miles east, 11 miles north, your point 9, 11 isn't going to be inside our arc here. The radius is 15. If you calculate the distance to that point from 0, 0 to 9, 11, you get 14.21, which is less than 15. So yes, you will get reception. Well, you really got to turn it off and enjoy the view. That's the way it ought to be. Number 20, write the standard form equation for this circle here, and also it says list 6 points that lie on the circle. So your standard, okay, so you've got your, you got to read it off the graph. So 1, 2 is your center, and if you're going from 1 out to 5, 2, you know your radius is 4. So you've got x minus 1 squared plus y minus 2 squared equals 16. Now just read the 4 points that are distance of 4 away, left and right, up and down from your center. So you get those 4 points right here, 1, negative 2, negative 3, 2, 5, 2, 1, 6. But we need 2 more. Find 2 more, just choose another value for x and plug it into your equation. And solve for y. And what you'll get is, like if you say y equals, if you solve for, what do we got? Where x equals 3, for example, that would give us 4 plus y minus 2 quantity squared equals 16. And you got y minus 2 quantity squared equals 12, so y ends up being, what? Plus or minus root 12 plus 2. And so you've got 2 plus or minus root 12. I solved it for y equals 0, and I got 1 plus or minus root 12. So it could have been a variety of answers on that. All right, did anybody get 17?
I tried.
You tried. And then what happened?
Is it, yes?
Yeah.
Is it y equals 3 plus x plus 6?
No, not exactly, but you're on the right track.
Yeah, y equals x plus 3.
Nope. Did anybody else get? What else did you get?
Y equals.
All right.
I just did
No.
I put in points like y minus 2 is the third of x plus 1. I told you it's not.
Close.
Is it actually?
Close. Let's see how we do it. What did you get, Julia? Do you want to tell us? Let's take a look at how we solve this thing. First of all, if we graph it, we draw the circle, and we know that this point, negative 5, 3, is going to have a line with a tangent on it. It's only one line. The tangent at that point is there's only one possibility. The center is at 0, 0 because it told us that in the equation, right? Okay. So the radius is root 34. We also know that from the equation. But what do we know then about this tangent line? Well, if you draw the radius out to that point, what's the relationship between the radius and the tangent? They're perpendicular. Yes, yes. So that's good. That's really good. Because to find out the equation of a line, you need the slope. We already have the point, we just need the slope. But if we can figure out the slope of the perpendicular, then we know the slope of the tangent. How do we find the slope of the perpendicular line, the radius? What is it? What's the slope of the radius at that point?
You can do it.
You have
can
everything
do
you
it from
need.
0, 0 to
Oh, the
So what's the slope of that line? What's the slope of that radius?
negative
Rise over run.
negative 5.
Negative 3/5. It's up 3 and left 5 from here, right? We draw it like this. If you go from 0, 0 to that point, you're going to go up 3 and left 5. So that gives you negative 3/5. So therefore, the tangent slope is the negative reciprocal of that, which is going to be 5/3. So you just write y minus 3 equals 5/3 x plus 5. And that is your point slope form. You could simplify it to slope intercept form if you want. You'd have y equals 5/3 x plus 34 over 3 is how that works out. You got it. Very good. Very good. Yeah. But this was kind of like next level, you know. So it was challenging, but not out of reach. I'm sorry?
Why did you find the opposite of it?
Because you don't know, you have a point for the line, but you don't have a slope. To have a slope, to have a line equation, you need a slope and a point.
Didn't we find the slope by doing
That's the slope of the radius, yeah, but not the slope of the tangent. See, this is the radius going this way. It's not drawn in. Can I draw it? No, I can't draw it. So that's the radius. It's perpendicular to the slope. I want the slope of this. But if I do have this, which is negative 3/5, I just know that the opposite of the reciprocal, which is going to be 5/3, will give me the slope. That's the slope of the tangent. All right. Any other questions on the homework? Okay. Let's finish up on our notes here. Next week, of course, we have Terra Nova testing. So what does that mean? It means block scheduling. So Monday, we do not meet. Tuesday and Wednesday, we do meet, and we will meet for 75 minutes.
On Wednesday, this is the first class of the day.
Okay. Imagine so much math. Isn't that great? Oh, but Wednesday's your test. Yeah.
Wait, hold on. So when are we going to review?
When? Well, we've got an exercise on Tuesday.
Oh, we have you Tuesday.
Oh, yeah, yeah.
Okay.
Yeah, we're not going to meet Monday, but we will meet Tuesday, and then we will test Wednesday. But you're not going to have all 75 minutes for the test, because that's overkill. I mean, who wants to take a test for 75 minutes? You do? Really? Wow. Just keep doing problems over and over again. Yeah. 2-hour test? Too long. I can't sit that long.
What classes on Monday do we have? 1, 2, 3, 4, and then 5. We have 5 every day.
So, right, I think it goes 1, 2, 3, 4, 6, 7, 1, 2.
No, it's 1, 2, and
Uh-huh.
lunch,
Then the lunch, then 5,
and then 4.
then 4.
And
Okay.
it's 3, 4, 6, 7.
3, 4, 6, 7, 6, 7, 1, 2. Yeah. Okay. So in your first period class, I'm sure they'll circulate the schedule so that you can kind of get that straight. All right. Let's revisit our Conics notes here. We're going to talk about hyperbolas. We got everything done on our parabolas yesterday, right? That's still ellipses. We did that. So, okay. That's right. You're welcome. Yeah. Okay. So, oh, you know what? Let's.
So it's the space probe thing that we were talking about?
Yes, yes.
That's what I think.
All right. Low. There we go. All right. There's a cool thing that astronomers do, that NASA does when they send these space probes out into outer space. There's no way that you can put enough fuel on this thing to make the whole journey. You know, the Voyager space probes and others that go out past Jupiter, Saturn, and all that, they don't have enough fuel to make that whole trip on rocket engines. What they do is they get these things close to a planet and use the planet's gravity as a boost, they call it a slingshot or a gravity assist, so that it helps the satellite get on path to where it needs to go. What you got to know about astronomy is anything that's out in the solar system is going to start orbiting. It's going to start in elliptical orbit, and it's going to continue in that orbit based on how far away it is from that central object. Anything that we send out, satellites that we send outside the Earth, they will orbit around the Earth, and they will just stay stuck in that orbit until something else comes along and nudges it and pushes it further out. So, or they will stay exactly where they are until something brings it closer. We have probes that are going away from us, and we also have probes that are going toward the sun. There is the Parker solar probe that's going toward the sun. It's got this massive heat shield, and the heat shield is what's facing the sun and blocking all of the sensitive electronics on this thing from damage from the sun. But it's heading that way, and it gets close to Venus, and then it gets when it gets close enough to Venus, it spins inward and speeds up so that it can get closer to the sun. The probes that are going out, what they do is they approach the planet from the opposite direction, and they slow down so that they can go further out. And what we have is this gravity assist thing. What it does is as it approaches that planet, it takes on a hyperbolic path, where it kind of breaks out of its elliptical orbit, takes a hyperbola path, and is able to shoot out further or shoot in closer, depending on which thing you're looking at. And that will be that's a practical use for this thing called a hyperbola. Because hyperbola is kind of like the odd guy. You know, like if you were going to do the superlatives at the end of the year for conic sections, you know, like best looking, I think circle would be best looking. Yeah. Most likely to succeed. Most well-rounded.
We should do that. We should use it.
I'm thinking like the circle is most likely to succeed because they really go places.
They're really well-rounded.
They're well-rounded.
Alright, somebody does that.
But now hyperbola, I mean, what are you going to give hyperbola?
Drama.
Most outgoing?
Most likely to go
There's
around.
like a hyperbole.
Most likely.
Well, you know, most outgoing, I think so because look, it's going out in 4 directions, right? I did make a joke. The superlative for a hyperbola would be most outgoing,
Most
Going
going.
now.
right? Because it's going out of here, it's going out of there, it's going out of there, it's going out of there. Yeah. Most outgoing, yeah. So, I don't know, do you have another one for, I don't know, we could probably think of other ones for ellipses and parabolas. You guys work on that, but that's kind of what I thought up here. But anyway, what is a hyperbola? Remember when we had the cones, right? The conic section, when we sliced it vertically down, we cut into both cones and made this kind of parabolic type shape, but it was a little different because it was going two ways in the opposite directions. So you have this thing, it's got on the inside, it's got some fixed point called the focus. It's got a line outside of it called the directrix. And they've got a special way to calculate for every point on this thing. The distance between the point on the curve and the focus relates to the point on the curve and the directrix. That ratio is what's called the eccentricity. All conic sections have eccentricity of some value. And that's what distinguishes them all from each other. But with the hyperbola, we do see that this eccentricity, this ratio, is always greater than 1 for a hyperbola. For a parabola, it equals 1. For an ellipse, it's less than 1. For a circle, it's equal to 0. But with the parabola, we're always going to have some sort of a ratio greater than 1 between this point distance and that distance. Now, what does this look like as far as some of the other kind of anatomy of a hyperbola? You've got a vertex where in here. You've got an axis of symmetry like you did with a parabola. This axis of symmetry, of course, everything is the same top and bottom. You've got a focus inside there somewhere that's got a special relationship to the curve. And then you have these diagonal things. We saw those earlier in the year. These diagonals where the curve approaches them but doesn't cross them. What do we call them? Asymptotes, right? So these asymptotes will actually help us graph these hyperbolas. And it's kind of a cool technique that we're going to use to do a real fast sketch of a hyperbola using these diagonals. And let's take a look at that. First of all, we're going to find A and B from our equation. For example, x squared over 9 minus y squared over 4 equals 1. Okay, so the vertex, well, let's see. A is going to be under the positive term. B is going to be under the negative term. A little different than what we had in ellipses, right? Do you remember with ellipses, we said that the major axis was A, the minor axis was B? Okay? And that's how we were going to do that. Now here, what we'll have is the positive term will be over A, the negative term will be over B. Because what you're going to do is you're going to find the center. We find the center the same way. With this equation, of course the center is not really part of the curve. It's between the two parts of the curve, right? But it has a relationship there. We find the center, and then we go out left and right A, because if x is the positive term, we're going to go left and right A units to make our little box here. And we're going to go up and down B units. And from those distances, we're going to draw ourselves a rectangle. Then we're going to draw diagonals through the rectangle. And guess what? The diagonals are our asymptotes. Then on the axis of symmetry, that's where the vertex falls. Right on the edge of our rectangle. Right here at the center minus A, the center plus A. That's our vertex. So now what we have is we've got the diagonals, we got the vertex. So you come close to the diagonal, then you start to hook around toward the vertex, and then you go back down toward the diagonal again. Do the same thing on the other side. It's very fast, very quick, very easy to graph a hyperbola. All right, so when you find A and B, you see that A is under the positive term. B is under the negative term. Plot those, draw your rectangle, draw your diagonals, don't dray them. I gotta get my ink back. No. Where's my... Oh, there we and then sketch your hyperbola after that. All right. So if we were to sketch this one down here, x squared minus 9, x squared over 9 minus y squared over 4 equals 1. Tell you what, instead of doing a whole big thing, we've got a graph right here. We know that this is very symmetrical. I'm going to change this just a little bit, and we're going to imagine that this is our graph. Okay, so if we had x squared minus 9, what is our a? A equals 3, right? What is our b? B equals 2. So if you will forgive me for distorting this right here, this point is going to be, if we use this example to graph it up here, this would be negative 3, 0 as our vertex over here. We would say this is 3, 0 as our vertex over here. Then our b, we're going to have, of course, 0, negative 2, and 0, 2. What we would do is we would plot those points out, draw our rectangle to connect all those, draw our diagonals, and draw a curve. And that's how we would create that graph. Oh, we're having some issues. All right, let's do some multiple choice here. How to find the vertices. First of all, we're going to find a. That's the square root of the first term on the bottom. And then the vertices are at negative a and positive a. Negative a, 0, positive a, 0. So if that is true, then which of the choices above are the vertices of the hyperbola? X squared over 9 minus y squared over 16 equals 1. What's our correct choice? B and D? No, see, we're only going to have 2 vertices. We're not going to have the co-vertices like we did in the ellipse. All right? So what do you think, Joe? What's the better choice between B and D? Huh? D is correct, yes. So we have negative 3, 0 and 3, 0. If we're not centered at the origin, of course we are centered at the origin because we don't have another term there with the x. If we're not, then vertices are at h minus a, k, and h plus a, assuming that we have this same arrangement. All right, let's look at the next one and look closely at the next one. What are the vertices of the hyperbola y squared over 25 minus x squared over 64? That was awfully fast. Yes, that's right. It is the positive term. So what you're seeing is this thing is going to open up and down rather than side to side. All right? It's reoriented. So we're looking for the positive term. A is under the positive term. Good. All right, which of the following now is the graph of x squared over 36 minus y squared over 25 equals 1? What makes you say D, Alice? Okay. Good, good. And A, was A even a possibility? No, because we're not looking at an ellipse, we're looking at a hyperbola. Yeah, D is the correct answer. That's right. Good. How about this one? Which one of the following is a graph of x squared over 16 minus y squared over 49 equals 1? You think it's A? A or C, yeah, I'm with you there. But which one? That's right, that thingamajigger, yes. So you would have to do all the way up to 7, right? 4, up 7. So let's see how that, let's see, 7.
Like, I'm thinking. They look the same to me when I do it. I know, it's hard to say.
Is it getting very close?
Yes.
There? Well, I don't know. Oops.
My other one looks the same.
Really?
I mean, I know, mine looks the same too.
Well, if you just look at the curves,
I can just see those.
I'm going with C.
It's closer.
It seems to be opening more. There's a bigger difference, right? If you look at the difference between these two terms, 4 versus 7, it's a larger distance. If it was closer to 4, if this rectangle was squattier here, more like a square, what we would have is lines that'd be a lot closer to the curve. So, boy, that's looking weird. But yeah, C is correct answer. Okay. What's this called? A slice straight through a cone, parallel to its base. It is a circle. That's right. Yeah, just a couple little thrown in before we finish the day. And all right, which of the following is correct for the vertex of the parabola 2x squared plus 8x minus 12? Yeah, so these terms, local minimum, local maximum, refer to a turning point on the curve. I've got one vote for A. Anybody else want to vote? You got a vote for B. You got another vote for A.
Oh, no, wait. Hold on. No, let me change my...
Another vote for A.
No, it's definitely A.
No, I think
Hold on.
No,
No, I'm not.
no idea. I just spoke to you. Yeah, I think she's smarter than how many got
No, it's A. It's definitely A. Disregard my answer. I'm so sorry.
This says minimum at negative 220. This says local minimum at 220. Local maximum at negative 220. So there's a difference between A and B as far as minimum and maximum.
It's A.
Joe, what were you going to go for? D? Oh, we got to vote for D now. Okay. Well,
No, A.
another vote for A. All right. First of all, is the parabola upward or downward? It's upward because look, this A is positive. So if it's upward, it has a minimum, right? This is a minimum. That's the lowest it ever gets. And then it goes up from there. So we know it's got to be one of these two right here. And now it's figuring out, well, what's the vertex? You do vertex by what? Completing the square? Or negative B over 2A. It is A. You were right, Alex. Way to go. Way to be brave. You know, stick out there. All right. Rest of worksheet C is their homework. The numbers are on Red Web.
But we never went over how to find like foci.
Oh, you don't have to worry about it. We're not doing that this time around. Foci are so algebra 2.